In the winter of 1943, an Italian officer attached to German defensive positions along the Moro River in southeastern Italy penned a report that would circulate through Axis command centers with a mixture of disbelief and alarm. The officer described how Canadian engineering units had accomplished something that violated every principle of military logistics and terrain assessment he had been taught at the military academy in Rome. The Canadians, facing a landscape deliberately flooded by German engineers to create an impassable barrier, had not retreated or waited for the water to recede as any rational commander would have ordered. Instead, they had moved forward into the flood zone with equipment and techniques that transformed the submerged roads and fields into operational thoroughfares capable of supporting armor, artillery, and thousands of infantry soldiers. The Italian officer, a veteran of campaigns in North Africa and the Balkans, concluded his report with a statement that captured the bewilderment felt by Axis forces throughout the Italian theater. The Canadians possessed an engineering capability and an operational mindset that rendered conventional defensive tactics obsolete, turning obstacles that should have been insurmountable into mere inconveniences that delayed their advance by hours rather than weeks. The Italian campaign in the winter of 1943 and spring of 1944 presented some of the most challenging terrain and weather conditions of the entire Second World War, a brutal combination of mountains, rivers, and mud that favored defenders and punished attackers with a mercilessness that surpassed even the Western Front of the previous war. The German forces, under the command of Field Marshal Albert Kesselring, had established a series of defensive lines across the Italian peninsula that exploited every natural obstacle and turned the landscape itself into a weapon against the advancing Allies. Rivers were not merely defended but systematically flooded through the destruction of drainage systems and the deliberate breaching of levees, creating vast areas of impassable swamp that channeled attacking forces into killing zones covered by machine guns and artillery. Roads, essential for moving the heavy equipment that modern armies required, were destroyed not just by demolition, but by the removal of culverts and bridges in ways that made rapid repair nearly impossible. The Italian winter brought rain that fell with depressing regularity, turning the already sodden ground into a quagmire that swallowed vehicles and exhausted infantry soldiers who had to wade through knee-deep mud for every yard of advance. The Canadian forces assigned to the Italian theater in 1943 were part of the 1st Canadian Army, a formation that had earned a reputation for aggressive tactics and stubborn determination in previous campaigns, but had not yet faced the specific challenges that the Italian terrain presented. The Canadian engineers, organized into field companies attached to infantry and armored divisions, were equipped with standard bridging equipment, bulldozers, and mine-clearing tools that had proven adequate in other theaters, but were poorly suited to the conditions they would encounter in Italy. What set the Canadian engineers apart was not their equipment, which was often inferior to what British or American units possessed, but rather their approach to problem-solving and their willingness to improvise solutions that violated military doctrine and engineering textbooks. Many of the Canadian engineers had civilian backgrounds in construction, logging, and mining, industries that operated in the harsh Canadian wilderness where conventional methods often failed and success depended on adapting to local conditions and inventing techniques on the spot. The German and Italian defenders had studied the Canadian reputation from earlier campaigns and believed they understood the nature of the threat they would face. Intelligence reports characterized the Canadians as aggressive infantry fighters, with a tendency toward violence in close combat. But these assessments focused almost entirely on combat troops and paid little attention to support units like engineers. The assumption, widespread among Axis commanders, was that Canadian engineering capabilities were adequate for basic tasks, but lacked the sophistication and training that German pioneer units possessed. This underestimation was reinforced by cultural prejudices that dismissed colonial troops as second-tier forces, and by a failure to appreciate how much modern warfare depended on engineering and logistics rather than pure combat prowess. The defensive strategy employed by Kesselring assumed that Allied engineering units would follow predictable patterns, that flooded terrain would force long delays while water was pumped out or bypasses were constructed, and that the destruction of road networks would create bottlenecks that could be exploited through counterattacks and artillery fire. The first major test of Canadian engineering capabilities in Italy came in December 1943, as forces pushed toward the town of Ortona through a landscape that German engineers had systematically flooded by destroying pumping stations and breaching river levees. The Moro River, normally a modest stream easily crossed by infantry, had been transformed into a wide expanse of brown water that stretched across fields and roads, submerging everything to depths that made conventional fording impossible. German observers, watching from defensive positions on higher ground, expected the Canadian advance to halt for days or even weeks while engineers constructed bridges and cleared approach routes. What they witnessed instead was a demonstration of engineering innovation that defied expectations and rendered their carefully prepared defenses far less effective than planned. Canadian engineer units moved into the flood zone with amphibious vehicles, portable pontoon sections, and prefabricated bridge components that had been modified in field workshops to operate in conditions that exceeded their design specifications. Within hours of reaching the flooded area, the Canadians had established multiple crossing points and were moving armor and artillery across terrain that should have been completely impassable. The techniques employed by Canadian engineers in the Italian floods were born from a combination of formal training, improvisational genius, and a willingness to accept risks that more cautious commanders would have rejected. The standard approach to crossing a flooded area involved waiting for water levels to drop, conducting extensive reconnaissance to identify the original roadbed beneath the water, and then constructing elevated causeways or floating bridges that could support military traffic. This process typically required days or weeks of preparation and enormous quantities of engineering materials that had to be transported forward through already congested supply lines. The Canadians, facing pressure from commanders who demanded rapid advances and lacking the luxury of unlimited time and resources, developed a radically different approach that emphasized speed and calculated risk-taking over methodical preparation. Engineer reconnaissance teams would wade into flooded areas, using poles and ropes to map the submerged terrain and identify sections of road or firm ground that remained intact beneath the water. These teams, working in conditions that were cold, dangerous, and exhausting, would mark routes with buoys and stakes that provided visual guides for the columns that would follow. Once routes were identified, Canadian engineers would begin the process of making them passable for heavy vehicles, a challenge that required creative use of available materials and a willingness to employ techniques that would have horrified peacetime safety inspectors. Prefabricated bridge sections designed to span gaps in destroyed bridges were repurposed as floating platforms that could be anchored to submerged road surfaces, creating a partially elevated pathway through water that was too deep for vehicles to ford, but not deep enough to require full-scale bridges. Amphibious carriers, awkward vehicles that were neither boats nor trucks, but attempted to combine the worst characteristics of both, were pressed into service as ferries and material transporters, shuttling loads across sections of flood that were too wide for bridge sections to span. Bulldozers, their exhausts extended with improvised snorkels made from fuel drums and pipe, would operate in water up to their cab roofs, pushing debris aside and leveling submerged road surfaces to create more stable foundations for the traffic that would follow. The entire operation had a chaotic, improvised quality that disturbed senior officers who visited the front and saw what appeared to be dangerous confusion, but was actually a highly organized chaos that achieved results conventional methods could not match. The Italian and German defenders, watching these operations through binoculars and artillery observation posts, struggled to understand what they were seeing. Military doctrine, whether German, Italian, British, or American, treated flooded terrain as an absolute barrier that required extensive engineering work to overcome. The speed at which the Canadians were moving through obstacles that should have stopped them for days suggested either that the flooding was less extensive than German engineers had achieved, which was demonstrably not true, or that the Canadians possessed engineering capabilities that exceeded anything in Axis experience. Initial reports from Italian officers were dismissed by German commanders as exaggerations or misunderstandings, reflections of declining Italian morale rather than accurate assessments of Canadian capabilities. This dismissal persisted until German engineer officers conducted their own observations and confirmed that the Canadians were indeed accomplishing what had been deemed impossible. The implications were disturbing, suggesting that the defensive strategy built around terrain obstacles was far less effective than had been assumed. The human cost of these engineering operations was substantial, though it received far less attention than the casualties suffered by infantry units in direct combat. Engineers working in flooded terrain faced constant danger from enemy artillery and sniper fire, from equipment failures that could trap or drown operators, and from the simple physical exhaustion of working for hours in cold water while wearing heavy gear and maneuvering equipment at the limits of its capabilities. The cold was particularly brutal, with water temperatures in the Italian winter hovering just above freezing, leading to cases of hypothermia that incapacitated men even when they had not been wounded. Engineers who fell into deeper water while working on underwater obstructions or who were trapped when vehicles tipped over in submerged ditches often drowned before rescue could be effected, their bodies sometimes not recovered until months later when floodwaters finally receded. The psychological toll was equally severe, as the work required sustained concentration and physical effort under conditions that would have broken less motivated troops. Yet the engineer units maintained their effectiveness through a combination of unit pride, leadership that shared the hardships of the ranks, and a grim determination to prove that Canadian forces could overcome any obstacle the enemy could create. The transformation of flooded roads into operational battlefields required more than just engineering skill. It demanded a complete reimagining of how military operations could be conducted in terrain that conventional wisdom deemed impassable. Canadian commanders learned to move artillery forward through partially flooded areas, positioning guns on hastily constructed platforms that kept them above water while allowing them to provide fire support for advancing infantry. Ammunition and supplies were moved forward using any vehicle that could float or wade, including commandeered civilian boats, improvised rafts constructed from empty fuel drums and timber, and even swimming tanks that had been designed for amphibious assaults but proved useful for crossing flooded fields. Infantry tactics were adapted to account for the fact that soldiers might be advancing through knee-deep water under fire, requiring modified weapons handling procedures and acceptance of casualty rates that would have been unacceptable in dry terrain. The entire operation became a demonstration of institutional flexibility and tactical innovation that stood in sharp contrast to the more rigid operational approaches that characterized many military organizations of the period. The Canadians proved that an army's effectiveness was determined not just by its equipment and training, but by its ability to adapt to unexpected conditions and to develop novel solutions when standard procedures proved inadequate. The climax of the Canadian engineering operations in flooded terrain came during the advance on the Arielle River in late December 1943 and early January 1944, a period when German defensive positions seemed nearly impregnable and when Allied commanders were seriously considering halting the offensive until spring weather improved conditions. The Arielle sector had been fortified with typical German thoroughness, with defensive positions on high ground overlooking approaches that had been deliberately flooded to create a barrier several hundred yards wide. German machine gun positions and mortar pits commanded every potential crossing point, while artillery observers on distant hills could call down devastating fire on any concentration of Allied troops or vehicles. The Italian officers attached to German units in this sector, veterans who had observed Canadian operations elsewhere along the front, warned their German counterparts that the Canadians would find a way to cross despite the obstacles. These warnings were received with polite skepticism, as German engineers had personally supervised the flooding and were confident that the water was too deep and the mud too soft to permit any kind of rapid crossing even by highly skilled engineer units. The Canadian assault on the Arielle positions began not with a conventional attack, but with an engineering operation that demonstrated the full extent of the innovations that had been developed through months of operations in flooded terrain. Rather than attempting to build bridges or causeways at obvious crossing points where German defenses were strongest, Canadian engineers identified sections of the flood zone where aerial reconnaissance and local intelligence suggested that intact roadbeds remained submerged at relatively shallow depths. Work parties moved forward under cover of darkness and smoke screens, wading into the icy water to emplace markers and to begin the process of creating passable routes through obstacles that were as much psychological as physical. The Germans, alert to the possibility of crossing attempts, laid down harassing artillery fire that turned the water into a maelstrom of exploding shells and geysers of mud, killing and wounding engineers who had no cover and could only press forward or retreat. Yet the work continued, with casualties being replaced by fresh troops who stepped into the water to take up the tasks of fallen comrades, motivated by a combination of duty and pride that refused to accept failure. By dawn, the impossible had been achieved. Multiple routes through the flooded zone had been marked and partially prepared, with submerged road surfaces cleared of the worst obstructions and with pontoon sections and portable bridges positioned to create elevated pathways across the deepest sections. Canadian armor began moving forward, guided by engineers who walked ahead through waist-deep water to ensure that vehicles stayed on the prepared routes and did not slide off into deeper channels where they would become hopelessly bogged down. The sight of tanks emerging from water that should have been impassable shocked the German defenders, disrupting carefully planned fire missions and creating uncertainty about where the main Canadian thrust would develop. Italian observers, positioned to provide local knowledge and liaise with German command, watched with a mixture of professional respect and personal dismay as the defenses they had helped design were circumvented through engineering audacity that seemed to defy military logic. The battle that followed was chaotic and brutal, with combat occurring in and around water that hampered movement for both attackers and defenders. Canadian infantry, having crossed the flooded zone on foot or aboard amphibious carriers, assaulted German positions that were now threatened from angles that the defenders had considered impossible to approach. The combat devolved into a series of small unit actions fought in mud and water, with grenades and automatic weapons fire punctuated by the crack of artillery shells that were falling dangerously close to both sides as forward observers struggled to identify targets in the confusion. German defenders, many of whom were experienced veterans of the Eastern Front and other campaigns, found themselves fighting an enemy who seemed to accept conditions that would have stopped other forces, who pressed forward through terrain that should have exhausted and demoralized them, and who maintained offensive momentum even when casualties mounted, and when rational assessments suggested that withdrawal was the prudent course. The psychological impact of this relentlessness was as significant as the physical pressure, creating a sense among Axis troops that conventional defensive tactics were inadequate against an opponent who could engineer solutions to any obstacle. The crossing of the Arieli flood zone cost the Canadian forces heavily, with engineer units suffering casualty rates that approached those of frontline infantry formations. Entire work parties were wiped out by artillery concentrations, vehicles were lost to hidden submerged obstacles or to mechanical failures that could not be repaired in the field, and individual engineers drowned or died from exposure during the long hours of work in freezing water. The Butcher's Bill, as soldiers grimly called the casualty lists, reflected the reality that the engineering war was every bit as deadly as the combat war, and that the unglamorous work of making advances possible exacted a price in blood and suffering that matched or exceeded what was paid in direct firefights. Yet the crossing succeeded. The German defensive line was breached, and the Italian officers who had predicted Canadian success found themselves vindicated even as they contemplated the implications of serving alongside an ally who was being outfought by colonial troops that Nazi ideology insisted should be inferior. The shock of witnessing these operations, of seeing doctrines proven wrong and assumptions shattered, would color Italian military assessments of Allied capabilities for the remainder of the war and would contribute to the demoralization that increasingly afflicted Axis forces in Italy as they realized that they faced enemies who could not be stopped by terrain alone. The aftermath of the Arieli crossing and similar operations throughout the Italian campaign forced a reassessment of engineering doctrine within Allied armies, and created ripple effects that influenced how military forces would approach obstacles in future conflicts. The techniques developed by Canadian engineers in response to the specific conditions of flooded Italian terrain were studied, documented, and eventually incorporated into training programs and field manuals throughout the British Commonwealth and American military establishments. What had begun as improvised responses to immediate tactical challenges became systematized knowledge that could be taught to new engineer units and adapted to different environments. The speed at which this institutional learning occurred reflected both the urgency of wartime conditions and the recognition that the Canadians had stumbled upon solutions to problems that had vexed military engineers for generations. The ability to rapidly cross flooded or heavily damaged terrain while maintaining offensive momentum was not just a tactical advantage, but a strategic capability that altered the calculus of defensive warfare and made static defensive lines far less effective than they had been in previous conflicts. The Italian campaign also revealed the extent to which modern warfare had become as much about engineering and logistics as about direct combat between infantry and armor formations. The romantic notion of warfare as primarily a contest of courage and fighting spirit, still prevalent in some military circles despite the lessons of the First World War, was definitively laid to rest by the Italian experience. Battles were won or lost based on which side could move supplies forward, maintain vehicles in working order, and overcome terrain obstacles faster than the enemy could create them. The Canadian engineers, often overlooked in popular accounts that focused on infantry battles and armor clashes, were the unsung architects of Allied success in Italy, enabling advances that would have been impossible if left to combat troops alone. This reality was understood by professional military officers, but was often lost on civilian populations and even on many soldiers who saw only the immediate combat and not the infrastructure of support that made that combat possible. The engineers worked in obscurity, their achievements measured in miles of road repaired and rivers bridged rather than in enemy soldiers killed or ground captured, yet their contributions were as essential as those of any combat formation. The psychological impact of Canadian engineering success extended beyond the immediate tactical situations where flooded roads were transformed into operational routes. German and Italian forces throughout the Italian theater began to question whether any defensive position was truly secure, whether any obstacle was actually impassable if Canadian engineers were given time to study it and apply their unorthodox methods. This erosion of confidence in defensive preparations had strategic consequences, making Axis commanders more cautious about committing to defensive lines and more willing to withdraw, rather than risk being outflanked by forces that could move through terrain that should have been blocking. The Canadian reputation, already formidable due to the combat performance of infantry and armor units, was enhanced by the recognition that Canadian forces possessed engineering capabilities that allowed them to operate in conditions that would have stopped other armies. This reputation became a psychological weapon in itself, creating doubt and uncertainty among enemy commanders who had to plan defenses without being certain what obstacles would actually prove effective. The human stories behind the engineering operations in Italy reflect the broader experience of ordinary soldiers thrust into extraordinary circumstances and forced to perform tasks that exceeded anything they had trained for or imagined during peacetime. Engineers who had worked as carpenters, mechanics, or heavy equipment operators in civilian life found themselves directing complex military operations, making decisions that affected the lives of thousands of soldiers, and improvising solutions to problems that had no textbook answers. The transition from civilian to military engineer was never complete, as the men retained habits of thought and approaches to problem-solving that differed from those of career military officers. This difference, sometimes seen as a liability by regular Army personnel, proved to be an advantage in conditions that required flexibility and innovation rather than adherence to established procedures. The engineers took pride in their ability to accomplish what others deemed impossible, developing a unit culture that celebrated clever solutions and successful improvisation, as much as traditional military virtues like courage under fire and obedience to orders. The legacy of Canadian engineering operations in Italy influenced post-war military development in ways that extended far beyond the immediate tactical lessons. The recognition that engineering capability was a combat multiplier that could determine the outcome of campaigns led to increased investment in engineer training and equipment, to the development of specialized vehicles and tools for operating in difficult terrain. and to changes in operational doctrine that gave engineers a more central role in planning and executing military operations. The Cold War armies that emerged in the decades after 1945 reflected these lessons, with engineer units that were larger, better equipped, and more integrated into combat formations than had been the case in earlier conflicts. The Canadian contribution to this evolution was significant, as the improvised techniques developed in Italian floodwaters became the foundation for more sophisticated approaches to mobility and obstacle crossing. The engineers who waded through freezing water under fire to mark routes and clear obstructions had unwittingly contributed to a transformation in how armies understood and approached the relationship between terrain, technology, and tactical success. The final phase of the Italian campaign saw Canadian engineer units continue to demonstrate the capabilities that had shocked Axis observers during the winter battles, adapting their techniques to different terrain and different obstacles as the front moved northward through the spring and summer of 1944. The mountainous terrain of central Italy presented challenges that differed from the flooded plains of the coastal regions, with narrow mountain roads, destroyed bridges spanning deep gorges, and defensive positions built into rocky slopes that seemed impervious to assault. Yet the fundamental approach that had proven successful in the floods remained applicable: rapid reconnaissance, creative use of available materials, and a willingness to accept risks in exchange for speed. Canadian engineers became expert at constructing Bailey bridges, the modular steel structures that could be assembled quickly to span gaps created by destroyed permanent bridges, often working under fire and at night to minimize exposure to enemy artillery. They learned to use explosives not just for demolition, but for cutting roads through rock faces and for creating diversions that channeled water away from routes that needed to be kept dry. The accumulation of experience and the transmission of lessons learned from veteran units to newly arrived formations created an institutional capability that made each successive operation more efficient than the last. The reactions of Italian officers and soldiers to Canadian engineering prowess evolved over the course of the campaign, moving from initial shock and disbelief to grudging respect, and eventually to a kind of fatalistic acceptance that Canadian forces could overcome whatever obstacles were placed in their path. Italian units, increasingly demoralized by the long retreat up the peninsula and by the recognition that the war was lost, often surrendered more readily to Canadian forces than to other Allied formations, calculating that capture by the Canadians offered better odds of survival and decent treatment than continuing to fight alongside German forces that showed little concern for their Italian allies. This preference, noted in Allied intelligence reports and in the memoirs of Italian soldiers, reflected a recognition that the Canadians, while formidable in combat, were also professional soldiers who generally adhered to the rules of war regarding prisoners. The shock that Italian officers had experienced when first confronting Canadian capabilities gave way to a more nuanced understanding that combined military respect with personal relief that they were facing enemies who could defeat them quickly rather than grinding them down through prolonged combat. The cost of the Italian campaign for Canadian engineer units was measured not just in casualties, but in the physical and psychological toll of sustained operations under brutal conditions. Many engineers who survived the war carried permanent injuries from exposure, from accidents with heavy equipment, and from the cumulative stress of working for months in dangerous environments with inadequate rest. The psychological impact was equally significant, as men who had witnessed friends die in accidents or under fire struggled with guilt and trauma that was poorly understood in an era when post-traumatic stress disorder had not yet been named or widely recognized as a medical condition. The veterans returned to Canada after the war, carrying memories that they often could not share with civilian families who had no frame of reference for understanding what they had experienced. Some found purpose in continuing to work in construction or engineering, channeling their wartime experience into productive civilian careers. Others struggled with the transition, finding peacetime life meaningless after the intensity and purpose of wartime service. The collective memory of the engineer units, preserved in regimental histories and veterans associations, emphasized the technical achievements and the successful operations while sometimes glossing over the human cost and the lingering wounds that many carried. The transformation of Canadian national identity during and after the Second World War owed much to stories of military effectiveness and innovation, narratives that portrayed Canadians as pragmatic problem solvers who could match or exceed the capabilities of larger powers when circumstances demanded it. The engineering operations in Italy fit perfectly into this narrative, providing concrete examples of Canadian ingenuity and determination that could be celebrated without the moral ambiguity that sometimes surrounded infantry operations, where the line between necessary force and excessive violence could be unclear. The engineers had won their battles through skill and hard work rather than through killing, making their story more palatable to post-war audiences who wanted to honor military service while moving beyond the violence of war. This sanitized version of events, while not entirely inaccurate, simplified a more complex reality where engineering operations had been just as deadly and traumatic as infantry combat, where men had died in accidents or under fire while building the roads and bridges that enabled the advance, and where the distinction between combat soldiers and support troops had been far less clear than peacetime narratives suggested. The final reckoning of Canadian engineering achievements in Italy came decades after the war, as military historians and veterans themselves reflected on what had been accomplished and at what cost. The consensus that emerged recognized that Canadian engineers had indeed performed at an exceptional level, developing innovative techniques that influenced military practice for generations and enabling operations that would have been impossible with more conventional approaches. Yet this recognition was tempered by awareness of the price paid, the lives lost and bodies broken in service of objectives whose strategic value was sometimes questionable. The Italian campaign, with its grinding advances through difficult terrain against determined opposition, never achieved the decisive breakthrough that might have justified the casualties suffered. The engineering victories, impressive as they were, contributed to a campaign that ultimately succeeded, but that also consumed resources and lives that might have been better employed elsewhere. This ambiguity, the tension between pride in achievement and sorrow for the cost, characterized the veterans' relationship with their wartime service and shaped how the Italian campaign was remembered in Canadian military history. The shock that Italian officers had experienced when first seeing Canadian engineers turn flooded roads into battlefields became part of a larger story about Canadian military effectiveness, a story that celebrated capability and innovation while remaining aware that these qualities had been purchased through sacrifice and suffering that would mark a generation.